start afresh. So when I say start afresh, we will go from unit 1 till unit 13 of SAT prep, and all of you who have, yeah, and Ananya was also missing. So hey Ananya. So what I was saying was, we have been doing things in different sprints. We pick up one unit, then we learn the concept, then we do some practice, and then again pick up some other unit. And that was all because some of you were wanting to give the SAT exam a little ahead of time. Some of you who are in higher grade, they were trying to do the SAT prep exam before, so they had some topics or units that they had selected. So that's why we were not going in a organized sequence. Now, yesterday, what we did was we just kind of looked through the syllabus, saying, okay, these are the topics that we have. So Pranit, you did not miss anything, neither did Vaibhav. So because we did not learn anything new, we just tried taking a look at the entire syllabus and see what are the things that we need to know and learn, and what are the things among those topics or units that is not so familiar to, that we are not familiar with. So now, yesterday I requested, and I'm repeating one more time, it is primarily for Ritika, Pranit and Vaibhav. And Sunarka, you were there in the class yesterday, right?
Yes, sir.
Okay, yeah. So primarily for kids who missed the class yesterday, where I requested each one of you to open up Khan Academy online, okay, outside the class, and go to Digital SAT Prep, glance through each and every unit, one by one, just the topics. Just look at, okay, unit 1, this. Let's look at what are the subjects or topics that I need to know, and mark the ones that you are not very comfortable with. Compile it for yourself and send it to me. So if each one of you give me 4 topics, let's say that these are 4 topics that I'm not really comfortable with, right? Then I'll compile them all and then start covering those topics one by one in a sequence. Because if I go by the syllabus that we have in Digital SAT Prep alone, there will be some of the topics that will be very easy, where some of you will get bored and tired, saying, oh no, this is something that we know, like tip of my finger, I can solve it. So we don't have to spend so much energy. So that's what I'm saying. Each one of you go through Khan Academy, spend half an hour between now and next Friday. Let's say till Thursday. So if you guys compile your list of topics, say, okay, these 4 topics, plotting polynomials. Let's say that is one topic. Likewise, list down 4, 5, 6 topics, or if 10, that's okay. Saying these are the 10 or 12 topics that I'm completely unaware of. I would want you to pick up those in priority and then teach them. So once I get the complete list, I'll consolidate, and that becomes my Bible for going through all these concepts one after another. Okay? That's what we'll try to do in next 2.5 months before the end of this year, and then from January we will start with unit 1 and then go in a sequence one by one, and then we'll try doing a lot of prep test also. So it will be like mimicking how the SAT exam would be and how you are performing in those exams when you see those questions for yourself. Is that okay? Everybody okay with that?
Yes, sir.
Okay, so send me the list of topics after going through the entire syllabus, just the syllabus, not the problems, not the concepts. I'm saying just look at the topics and list the topics which you would want me to cover for you, okay? Each one of you. And I would assume that I will get that list from most of you, if not 100%, at least 90% of you, before end of next Thursday, yeah? So that I'll use Friday to prepare for the first 2 topics that I'm going to cover, and then we'll go in a sequence one after another. Yeah?
Yes, sir.
So whoever has not said yes, they are silently saying yes is what I would assume.
Yes, sir.
Okay, alright. So Arya said that she is not feeling well, she will not be able to join. Okay. So let's start. So what is that we are going to cover today? I sent a message a little bit ago saying this is the topic that we are going to cover. So if I read that for you guys, I wanted to cover dealing with quadratic functions and then expressions with third degree and more, meaning zeros and zeros of polynomial remainder theorem. So these are the three things that we wanted to cover today. Let's see what all we can cover. So we'll start with plotting quadratic equations. Now, when I say we'll start with plotting quadratic equations, first of all, I would not assume that everybody in the class knows quadratic equation, okay? So that's why I will ask one more time. Can somebody explain me what is a quadratic equation? I'll come to Pranit towards the end. Let's see what I hear from the screen, because I've asked this question to you multiple times. So anybody on the screen, can somebody on the screen explain me?
An equation that has degree of 2.
Degree of 2, okay, yeah, okay. Anybody else? Whatever you know about quadratic equation, just spit it out. Any other thing?
It makes a parabola.
Makes a parabola, okay. Bible has given 2 clues. Yeah, Ritika.
It has a maximum of 2 solutions.
It can have maximum of 2 solutions. Okay, that's another good example. Okay, what else? Yeah.
Lowest to the highest point is the vertex of the parabola.
Lowest to the highest point is vertex of the parabola. So there is no highest point that you would ever know, because parabola can keep on going or keep going downward. So
Yes, the highest.
highest point or lowest point. Okay, got it. So you're saying that when you use a quadratic equation or expression to plot plot it on the coordinate plane. So if the I've been throwing markers more than 3 to 4 in a day. Let's see how long it lasts. So if this is my coordinate plane, if the parabola is plotted like this, the lowest point here is the vertex. If the parabola is facing upside down, then this is the highest point and that is called the vertex. So highest or lowest point of the parabola is called vertex. That's what you're saying. Okay. Okay. What else? Any other interesting information that you guys want to share with me?
Where a is not equal to 0.
Say that again.
When there is no a is not equal to 0. Like a is not equal to 0.
A is not equal to 0. What is A here? We have not talked about A yet.
Oh, I'm talking about ax squared plus
So the
bx.
so you're saying x squared plus bx plus c. Yeah. And this
And then where a is not equal to 0.
A is not equal to 0. Obviously that makes sense, because if A is 0, this whole thing becomes a linear equation. Yeah.
Yeah.
Okay. Alright. So this is about quadratic equations, or you can call it quadratic equation, you can call it, if you don't have anything here, this becomes a quadratic expression. If you write this as y equals to fx equals this, y is a function of x, and this form, then it becomes a quadratic function. Yeah. But quadratic, whenever you say quadratic, that simply means an equation or an expression where the maximum power to the variable is 2. Yeah. So now let's dig a little deeper inside it. So when we talk about a quadratic equation, let's say I have a quadratic equation y equals to 3x squared plus 4x minus not 7. Certainly not 7. I have written 7 so many times. Okay. So if I have an equation like this is a quadratic equation. Look here. Where what you see is the maximum power to the variable is 2. So that's the first criteria. Without that, you will not ever even dare to call it a quadratic function or equation. If I'm talking about only this is a linear equation. Maximum power to the variable is 1. Here the maximum power to the variable is 2. That is the only reason why we call it a quadratic equation. Now there are certain behaviors that we want to be aware of. Now, if this is a quadratic equation, you can write this in a standard form, which is like this. A quadratic equation can be represented in a standard form, which is like y equals to ax squared plus bx plus c, where a is the coefficient of x squared, b is the coefficient of the term which has an x to the power 1, and c is the constant, or you can say this is the term which has power to x equals 0. Everybody with me so far?
Yes, sir.
Okay. And even if I'm teaching something which sounds very childish, trust me, that is the building block for what we're going to learn. Okay, so bear with me if I'm teaching something very simple and known to you already. Now, so when you look at this, when Weber was saying that when a is not equal to 0. So when you look at any quadratic equation, you can simply try relating that in the standard form. This is the most specific one that we have, but this relates to the standard form. Any quadratic equation will be in this form. It might so happen that you have a quadratic equation which says y equals to 6x squared minus 3. That's it. But this is still a quadratic equation because the maximum power to the variable is 2. Now if you relate that with the standard form, you will say, okay, a equals 6, b equals 0. That is how the term with x disappeared. And then c equals minus 3. So you can always relate any quadratic equation with the standard form and find out what is the corresponding value of these variables or the coefficients of x squared, x and the constant term. Okay. So far, okay to digest? No problem with what we are discussing? Ritika, Aryan, Neil, Sarah, everybody?
Yes, sir.
Yes, sir.
Okay. Now I'll keep waking you guys up, okay? Because I don't feel confident till I hear a confident yes, okay? Alright. So this is just the basic building block of a quadratic equation when you talk about it. Now let's look at what actually happens if I have some equation like this. Just by looking at it, we can say, okay, y equals to 2x minus 17. So this is a linear equation. What it will do? It will plot a straight line. How do you use this equation for plotting a straight line on a coordinate plane? Everybody knows. You will just create a table and you will try finding out the value of x and you will try finding out the value of y for every value of x. So you will put x equals to 0, find out the value of y is minus 17. You will put x equals to 1, that gives you y equals to minus 15. You will put x equals to 4. I mean, you can keep choosing the numbers that you want to choose. X equals to 4, that becomes minus 9. And 3-4 points that you find out. So this becomes your coordinate for the first point, second point, third point. For drawing a line, you just need 2 points. So you will fit any 2 point into 2 point. 0 minus 17. So 0 minus 17. This is your 1 point. 1 and minus 15, second point. Join it. And that becomes your line. That part is clear, right? This part, no confusion, correct?
You randomly choose the numbers?
So you can decide. So basically, when you look at any linear equation or any quadratic equation, what is an equation? An equation is nothing but an agreement between the variables. That is how I'll put it. Here, they have signed a contract. X and Y have signed a contract saying, okay, my value and 2 times of your value. So my value will be equal to, let's say I am x and you are y, okay? So the deal between you and me is that 2 of Biren's value minus 17 would be Ananya's value. Okay? So this is a deal. Now I can keep playing with pi value. I mean this only the agreement is only for this relationship. This equation that you see. And every value has to stick to this agreement. So I say, okay, fine. How about I pick x equals to 0? Fine, you can choose x equals to 0. Then the value of y has to be 17. That's the only way this deal is honored. Yeah? X equals to 1. Then if I plug in the value of x equals to 1 here, it gets me y equal to 2 minus 17, which is equal to minus 15. Deal is honored. So that's how you build this table, and every combination of x and y becomes your one point, or the coordinates, x and y coordinates for that point. Yeah?
Okay, thank you.
I'm sorry?
I said thank you.
No problem. No, so I mean again, and there is no question that is wrong, okay? No question is a bad question. So feel free to ask, okay? I don't think anybody in the world would have explained it that way. That this, if you look at an equation, it's an agreement, right? You would have not heard that term agreement. I am kind of mining those terms so that it stays with you guys. Now, if I look at, let's say another equation. Now we were looking at a linear equation. So we said, okay, it's an agreement between x and y, the two variables, for a common outcome. If let's say I have an equation like y plus 3x equals to 15. This is the agreement between x and y, that whatever is the value of y, there will be a corresponding value of x, and these two together will fall into this agreement and give this outcome. So now, but this is a linear equation, so this plots a line. You will see that when you pick any 2 points, create the table and pick 2 points and join them, make the line. Any point that you pick on the line, find out the x and y coordinates, x and y value, fit in here. You will see they're honoring it as well. Okay? So any point on this line that you draw, which is built by finding out two points, any point that you pick up on this line will honor this contract. Okay? Now, same thing holds true for any equation. See, we say there is a good equation going on between the teacher and the student. What does it mean? It says that okay, the teacher and the students are going pretty well, meaning whatever teacher is explaining, students are able to follow. Whatever student is asking to explain, teacher is able to make them understand. So there is a good equation going between the teacher and student. Imagine you find me very highly unqualified. The equation between you guys and me will not go well for long enough. Okay? The day you find me unqualified or disqualified, you'll say, okay, fine, done. Let me talk to my dad and tell that, okay, this teacher is not even worthy of spending 15 minutes with him. Yeah? So when you say equation, this is nothing but, it just depicts a relationship, an agreement, a deal, whatever you call it. Okay? So that will hold true not only for linear equation, but for quadratic equation, any polynomial equation that you deal with. Okay? Now let's look at a quadratic equation. Y equals to 3x squared minus 4x plus 15. What do you see here? This is a quadratic equation. This is an equation or relationship between x and y, and this is a deal that we have signed. Saying for any value of x, let's say when I say x equals to 1, there will be a corresponding value of y. They cannot live in isolation. Meaning, I cannot say, okay, x equals to 1 and y equal to 17. I cannot say that blindly for this equation, because x and y values have to honor this agreement. Now if I say x equals to 1, what will be the value of y? Let's figure it out. If x equals to 1, 3 into 1 square minus 4 into 1 plus 15. So 3 minus 4 plus 15, that becomes 14. So y equals to 14. This is the only possibility for x value of x equals to 1. You cannot have x equals to 1 and y equals to 12. This is what this contract says. Okay. So what that means is every value of x will have a corresponding value of y, and that is what we use for plotting it on a coordinate plane. You will look at different combinations of x and y. Let's say x equals to 0. This is my equation. Let's say when x equals to 0, what is the value of y? Put it here. This becomes 0, this becomes 0, y equals to 15. Meaning, this point x is 0, y is 15. Let's say this is 5, this is 10, this is 15. Minus 5, minus 10, minus 15. This is, let's say, 5, 10, 15. And I'm assuming everybody is comfortable with the coordinate planes and this thing, right? Yeah? Everybody is comfortable, conceptually at least?
Yes.
Yes. And these coordinate planes are nothing but two number lines that you would have learned in grade 2 or 3. Okay? These are two number lines perpendicular to each other. The horizontal one we call as x-axis, this is called as y-axis. Okay? So I'll keep on giving you guys lame examples so that it stays with you as a concept. Okay? Now, this is my x-axis, this is my y-axis. So when x is 0, y is 15. X is 0, y is 15. So this is my one point. On the y-axis, this is my first point. So you can call this as a y-intercept, meaning this quality equation is going to plot a parabola for sure. Okay, that is one thing you have to believe me for now. And when you put x equals to 0, you got a value of y as 15, and that becomes your first point on the parabola. And this is also called y-intercept. Meaning, when x equals to 0, where it cuts the y-axis, that is called your y-intercept. Same way, when you put y equals to 0, meaning y equals 0. So when you put y equals to 0, this becomes 3x square minus 4x plus 15 equals 0. And you have to solve it for the value of x now. This is a simple quadratic equation. You have to solve it for x. Who all can solve this equation? Tell me what are the two values of x. 3x square minus 4x plus 15 equals to 0. Who all can solve it and tell me what are the two values of x? Yep.
You could do use the quadratic formula to find the two values.
Anyways, I mean, so you know it. Anybody in the class who doesn't know how to find out two values of x from this one? Or who doesn't remember or recall right now? No, I mean, don't try solving it. First of all, just answer me that if you have an equation like this and somebody says solve it for x, since this is a quadratic equation meaning x to the power 2, that means this is going to give me two solutions for x, two possible solutions for x. Now, I'm just curious to know if anybody in the class doesn't know how to solve it, you have to tell it so that I can just quickly run through this. And it's okay, I mean, if you have not done it, that's fine. No harm.
So you can solve this problem by doing factorizing and then
Okay.
and then you can use the quadratic formula.
Okay, you can use quadratic formula, you can use factorization, or you can also look at finding out
The a square plus b a square.
a into
plus
b
b
ab,
square.
a into b ab, yeah, or a plus b whole square, or whichever form you find comfortable with. Okay, so let me put some of you on the spot. So Sarah and Neil, have you dealt with this before? If you have to solve a quadratic equation, do you know how to solve it and get the answers? Neil, would you remember?
What?
If you have a quadratic equation like this and you have to find out the value of x, do you know how to find it?
I don't remember.
You don't remember. Okay. So let me quickly do this. Okay. What we'll do is, Neil, I would request you to put that as one of the topic. Okay, solving quadratic equation. That would be one of the topic that you will mention. Send it to me for this one. Okay. So that yeah. So now here a simple solution. Okay. Many of you know how to solve it. So I will say if I have an equation like this, coefficient of x squared is a, coefficient of x is called b, and the last constant is called c. There is a way you can say find out the two answers for x equals minus b plus minus b squared minus 4ac divided by 2a. Now here what is the value of b? B is minus 4. So minus into minus 4 plus minus b square minus 4ac. So b square becomes 16 minus 4ac. 4 3s are 12 into 15. 12 into 15 is 180. Divided by 2 into a, 2 into 3. So this gives you a negative. Square root of a negative. So this is not a possible. Yeah. This gives you a negative in the square root, right? So that's an imaginary number. So maybe the question I chose was not correct. I mean the equation that I chose was not exactly correct. Yeah. So anyways, so let's not try solving this one, but let's look at the concept part of it. So if I have any quadratic equation, okay, so basically you have to find out the points. I mean maybe this equation was not correct, that's why we were getting imaginary answer for this one. So this is called discriminant, okay, b square minus 4ac, and this value was giving a negative. So square root of a negative is considered an invalid number. So that's why I'm not trying to solve it right now. But briefly, if you look at it, if I have a quadratic equation, I can find out the combination of x and y, and let's say this was plus, that would have been so I'm just making it up, okay. If I get lost in solving this one, then probably the whole class will be gone solving this particular problem, but I'm trying to teach you guys the concept part of it. So when I said when x equals to 0, it gave me a value of y as 15. That means this is the y-intercept, meaning where the parabola is touching the y-axis. Similarly, when you put y equals to 0, where will the y be 0? On this entire x-axis. Anywhere you go on this x-axis, any place, the y coordinate will be 0. Okay. So by solving this for x, you will get 2 points, maximum 2 points, and when you join that, this plots your parabola. So you get 2 points here, and you can probably pick 1 or 2 more combination of x and y. You make your table of 4-5 points for x and y combination, and then you plot that. That plots your parabola. So far with the parabola, we had, or the quadratic equation, we had just understood what is a quadratic equation plots a parabola. That is something that I forced you guys to believe. Now we are just looking at what is an x and y intercept of a parabola. So x intercept of a parabola means where it will touch the x-axis. When will it touch the x-axis? Where y equals to 0. So you put y equals to 0 and solve it for x, and then you get 2 points. And then you already got 1 point. You probably can try finding out 2-3 more points based on this contract. You can put x equals to 1, x equals to 4. You can put some negative value of x equals to minus 2 also you can put. And see what is the corresponding value of y you get. And those combinations of x and y, you pick 2-3 points, and then you join them with a free hand, and then you will see this becomes a parabola. So far we have just talked about how do we plot a parabola, and it is nothing different from plotting a straight line. It's the same stuff. You have to find out x and y coordinate because you have a relationship, a contract or a deal given between x and y. So you keep picking different value of x, keep finding the corresponding value of y. X equals to 1, what is the value of y? X and y, that is one combination. Let's say x equals to 4, and then find out corresponding value of y. Change x to minus 2, see what is the corresponding value of y. That becomes your combination. Find out 5, 6 different points, just join them. Let's say you got 5 points. You join them one after another. That becomes your parabola. Now, I know we came across some confusing concept when we were trying to solve the quadratic equation, but then here, so far, whatever we have learned, is this part okay to digest conceptually? I have a quadratic equation, we are trying to plot the parabola, what is meant by x-intercept, what is meant by y-intercept, that's the only thing that we have talked about so far. Is that part clear so far?
Yes, sir.
Okay. Now, so there was one more thing that I talked about in the beginning and said, okay, any quadratic equation can be written as standard form as ax squared plus bx plus c. Yeah. So a is nothing but the coefficient of x squared, b is nothing but the coefficient of x, and c is nothing but the constant. There's so much of silence. I'm assuming everybody is with me. Yeah?
Yes, sir.
Okay. Now, this is my standard form of a parabola. Yeah? But how do I read or how do we make interpretation from this one? If, let's look at this. Let's take a simple example. Y equals to x squared minus 4. Okay? Let's plot it. See, this is a quadratic equation. Maximum power to the variable is 2. This is a quadratic equation. So let's find out how do we plot it. So everybody pay attention to this, okay? X and y. We are trying to find out different combination of x and y, okay? If I say x equals to 0, when x equals to 0, y is minus 4. Meaning, when x is 0, y is minus 4. Let's say this is 2, this is 4, this is 6. So this is my one point, meaning this is my y-intercept. This is where the parabola is touching the y-axis. Now, when I say y equals 0, when I say y equals 0, what happens? Y equals to 0. So x squared minus 4 equals to 0. That means x squared minus 2 squared equals 0. Now, if you look at this, this is a squared minus b squared form. That will be equal to a plus b into x, a minus b. X plus 2 into x minus 2 equals 0. Correct? A squared minus b squared equals a plus b into a minus b. Like the three generic formulas that we know. A plus b whole square equals a squared plus 2ab plus b squared. A minus b whole square is a squared minus 2ab plus b squared. And a squared minus b squared is a plus b into a minus b. So we are seeing the third form of the generic formula. A squared minus b squared equals a plus b into a minus b. A squared minus b squared. See? So a plus b and a minus b. So you got two answers for x. In this case, it becomes x equals to minus 2. If you look at this case, it becomes x equals plus 2. So you got two places where this parabola touches the x-axis, where the y coordinate is 0. A moment of silence. Am I going very fast? Am I confusing you guys?
No, sir.
No, sir, it's clear.
Clear? Okay. Ritika, Sarah, Neil, everybody clear?
Yes, sir.
Okay.
Yes, sir.
How about Ananya,
Yes, sir.
Sunalka with me?
Yes, sir.
Okay.
Yes, sir.
Wonderful, wonderful. I heard it loud and clear, Aryan. Thank you. So, yeah. So, basically, I got 2 points where it touches the x-axis, meaning where the y value is 0. we just put the y equals 0 and we got two values for x. So let's say this is 2, 4, 6, minus 2, minus 4, minus 6. I got one value as when I put x equals to 0, we got y equals to minus 4. This was by 1 point. When I put y equals to 0, I got two values for x. So 2 and minus 2. See, 3 points we got. You can probably play with it. So when you put y equals to 0, you got x equals to minus 2. And second scenario, you got y equals to x equals to plus 2. Now you can say, okay, fine, let me put x equals to 4. 4, x, when you put x equals to 4, this will be 4 square minus 4. So 16 minus 4, 12. You got when x equals to 4, y equals to 12. So let's say 2, 4, 6, 8, 10, 12. You got 4 and 12. You see, this is 12. You can put, okay, let's see, when we put x equals to 4, I got y equals to 12. Let me put x equals to minus 4. Let's see what happens. When I put x equals to minus 4, again same thing, y equals to 12. So basically you will see there's another point like this. So now you got 1, 2, 3, 4, 5 points. Just join them. This became your parabola. So I've just drawn a parabola with the equation, okay? I did not do anything fancy. I just chose different numbers of x and y because I was told that if this is the equation for a parabola, this is the agreement between x and y. They have agreed for this relationship. So I am just exploiting that relationship to get all the different values for x and y to find out the different combinations which will be lying on the parabola. Now you can blindly pick any point on the parabola and look at the x and y value. Plug in here, you will see this is also agreeing to the same term. Okay. Now, that was not the intent. I was trying to tell you about something else. Here, if you look at this parabola equation, y equals to x square minus 4, and you try relating that with the standard form, y equals to ax square plus bx plus c. What is the value of a that you see with this equation? A is 1. Okay? Everybody saw that, right? If this is the standard form, if I relate that with this equation, this is the standard form for the parabola, this is the standard form, this is the equation that I have. What is the value of b? B is 0. What is the value of c? C is minus 4. I am more interested in the value of a. If my c, look at this guy, my parabola is facing upward. Do you know why? Because a is a positive number. A is positive, greater than 0. If you really want to mess with this, just change this to minus x square. You will see the same parabola flips upside down. Okay? So, what is the interpretation from this? If you have a quadratic equation, look at the coefficient of x squared. If that is a positive number, your parabola is facing upward. If the coefficient of x squared is a negative number, meaning smaller than 0, it will be facing downward. If you guys don't trust me, I'll be more than happy. Because you can play with this literally. Just take or make any parabola equation with a being negative and just try plotting in a coordinate plane. And that is exactly what math is supposed to be. Don't trust your teacher. Don't trust your friends. I'm saying that if this is positive, since this was positive, that's why this parabola is this way. If this would have been negative, this would have faced downward. Just waste one graph paper, write an equation by yourself where the value of a is negative, the coefficient of x squared is negative, and then try plotting it. If the parabola doesn't face downward, there is a problem with the teacher. Leave this teacher immediately. Yeah. Any questions so far? I mean, were you able to follow what I said? Okay. I heard a yes from Sivatsav. Neil and Sarah,
Yes, sir.
Okay. Ritika, you had a question?
Oh, no, so I was trying to do the thumbs up emoji, but I accidentally raised my hand.
That's okay. That anyway,
Yeah.
I mean, any which way, when the kids interact with me, I feel happy. So, be it thumbs up, thumbs down, as long as you're reacting, that gives me a comfort that yes, you guys are with me. Alright, but this part is clear, right? Now, all that talking I have done for last 10 minutes, the main purpose of that was to look at a quadratic equation and look at the coefficient of x squared, and that should give you a view. Now, let's talk about a very standard question that you will get in SAT. Okay? And don't blame me for leaking this question if you come across this in your first SAT exam. They'll say, okay, fine, I have an equation like y equals 2x squared minus 4x plus 82. Okay? There are four options you have. It plots a parabola like this. It plots a parabola like this. It plots a parabola like this. And plots a parabola like this. It's going to be a tedious job. If you create a table and then try solving it, it'll take half of your exam's time. What you have to do, you have to use elimination technique. First thing you look at is, what is the value of A? A is positive, greater than 0, it's 2. I mean, when I say A, I'm talking about the standard form. What is the value of A? 2. That is a positive number, meaning the parabola cannot face downward. Let's say if I have two options with parabola facing downward, I can kill those two options immediately. I don't need these two. These are waste of time. Now to choose between this one and this one. Okay? And how will you choose? Now look at this equation. In this case, see, just by looking at these two options, here the parabola is touching the x-axis, here it is not touching the x-axis. What will you do? Look at this one. So where will it touch the x-axis? Where the value of y is 0, right? So if you have a situation like this, you have to solve this equation to find out the corresponding value of x where y is 0. Meaning you have to solve it for 2x squared minus 4x plus 82 equals 0 and find out the two possible values of x. Another intelligent move. Do you want to solve it? Put the effort for solving it? Or just by looking at this, see, in this case it is solving for two values of x. That is why it is touching the x-axis. Here it's not touching the x-axis. Meaning, if I have no solution for this, then this is the case. If I have solution for this, this could be a possible case. Now, how do you find out no solution for this? You have to find out the discriminant. When you are dealing with a quadratic equation, if you have a discriminant whose value is imaginary, meaning your discriminant is a negative value, meaning your discriminant is b square minus 4ac. If this part is negative, then only you are talking about an imaginary value. Yeah? Find out the value of the discriminant. What is the value of b? b is 4, minus 4. What is the value of 4? So this square minus 4ac. 4 into a. Well, a is 2. Into c is 82. See? What did you get? 4 minus 4 square is 16. Minus 4 times 2 is 8 times 82. 8 2 is 16. 8 is 64 plus 165. You are getting a negative value. You are getting an imaginary situation. You have to find out the square root of a negative. That is what is your discriminant. This could be a possible answer. So without doing much of a calculation, while it was looking to be a scenario where you have to deal with a lot of calculation, plot the table, deal with x and y values, what did we do? We looked at elimination. Just by looking at A, we could rule out two of the options. Then we were talking about only these two. And when we look at these two, the first thing we say, okay, in this case I have a solution for, this is intercepting x-axis, meaning it has solution for y equals to 0, and this one doesn't have. How do I find out whether this is the case or this is the case? My only bet, if I have a ax squared plus bx plus c equals 0 as a quadratic equation, and two possible answers for that is minus b plus minus b square minus 4ac divided by 2a, where b square minus 4ac is my discriminant. If this becomes my imaginary value, that is the case when I am saying that I don't have potentially right value for x, where I cannot solve it for x, meaning it will not touch my x-axis. So if I see this discriminant being negative, my job is done. I don't really have to do a lot of tricky calculation. From this whole equation, what did we do? We mapped it with this formula, looked at a's value, and then we found out the discriminant. That's it. And this would take maximum 45 seconds to 1 minute. You're done. If you try plotting it the most conventional way, like how I was doing before, that might take you for a ride and then eat up a lot of your time, a lot of your precious time during the exam. So exam is not just about solving the problem. Exam is about very smartly using your time or eliminating wastage of time to do a better job and to be able to solve maximum number of questions that you already know about. Yeah. So I taught you guys two things here. One is your approach towards, so when you are in the exam, you will find out what are the questions that I can solve quickly and save time for the ones which anyways will take more time for me. And that is where you have to find out the questions that you can solve quickly and how you can eliminate wastage of time for solving some of the problems. Elimination is the key. How do you eliminate the options? Yeah? Was it making sense so far? And all of you who are planning to take the SETI exam in near future, sooner than others, just be ready for applying those elimination techniques. Alright? Okay. So, what did we do so far? We just looked at what is a quadratic equation. We looked at how do we interpret a quadratic equation, how do we look at the coefficient of x squared, make a decision out of that, and how do we use elimination techniques when we end up dealing with a quadratic equation scenario. Let me take a pause, bring a moment of silence and see if anybody has any questions so far. No questions? Here's Neil, Sarah, Ritika. No questions, is it?
No questions, sir.
Are you-
No, sir.
Okay. So are you guys saying I'm a great teacher then? No, I'm just kidding. I'm still a student. I'm learning every time when I'm trying to teach you guys. Okay. Alright. So let's move on. So we talked about a quadratic equation. We talked about how do we interpret a quadratic equation. We looked at how do we use different elimination techniques for finding the right option from a quadratic equation. So I had given a lot of options today with respect to the things that we are going to learn, but I don't think we can, because now there's one more feedback that I'm getting from some of the parents saying that you are probably going way too fast. Go slow, make sure that you keep beating the drum again and again so that kids are able to follow it. So that's why I'm going a little slow, but making sure that whatever we learn in the class, we don't tend to miss that. Okay. Alright. Now there is something more. We have 10 more minutes, 8 more minutes. So I'm just thinking what would be the right thing to start and talk about. So, okay. Yeah. So we talked about parabola, we talked about x and y intercepts, and I just touched the word vertex. If I say vertex of a parabola, is the highest or the lowest point, like what Praneeth was saying. Correct? Now, if I asked you guys how to find out the coordinates of a vertex, how would you do that? Let's say if I have an equation like y equals to 3x squared plus 4x minus 6, and I say find out the coordinates of the vertex. Meaning, let's say if this is the parabola and this is positive, right? So I can blindly assume that okay, it will be facing upward. Okay? Now, I'm making guesses here. I'm saying that okay, just by looking at A, I know this is going to face upward. So I've just drawn one parabola. When I say vertex, we are talking about the lowest or the highest point. Find out the x and y coordinate of this parabola. Who all can tell me how would you find it? I don't need the answer, I need the approach. Yeah.
I would do, I set the discriminant to 0 and then do plug in the rest. That would give you the x value of this vertex, plug it into the real equation, and you get your y value for your vertex too.
Okay. Yes, Ritika.
I would just use the formula negative b over 2a to find x and plug in the value for x and then find the y value for it. So that would get me x and y.
So now, why would you even think about this? Why would you use this formula to find out the value of x? I'm just trying to get your concept, okay? So that we all can relate to it.
I would just always use that formula, so it was the first approach that I could think of.
Okay. Okay. So Shranvi, you have joined 6 minutes early. This is a very serious class for the high school students. You can probably, and Nihan, you also have joined early. So wait for 5 minutes and then we'll start for you guys. Alright. So, okay. So you said that you will find out the value of x by going for b minus 2a. So from this you will find out x, value of x equals to b by 2a, minus b by 2a. That means you are saying that this is the value for which your discriminant is 0. Yeah? Now, when you say discriminant is 0, my discriminant will be 0. So, when I have to solve this for this one, right? So, when I solve this k squared plus 4x equals minus 6 equals 0, and here I get two possible values of x, minus b plus minus b squared minus 4ac divided by 2a, okay? This is something I'm hearing from you and Praneeth both, so I'm just trying to, kind of build a concept out of it, okay? So, when I'm solving this for y equals to 0, I'm essentially talking about these 2 points, right? Where y is 0. So when I'm solving this for, okay, now you're saying that this point's x value is only this part. Any reason why? Tell me conceptually, okay? I mean, again, I'm trying to learn from you guys right now.
Because the vertex would be equidistant from both the solutions.
Okay. So this one is, okay, now look at this one. So this, here, this vertex will be equidistant from these places. What is the value of x here? This is where, okay, this is where the value of y is 0.
0.
So from this I am finding the value of x. For these two places, whatever is my value of x coordinate, right? This plus this divided by 2. Now here, I should be ideally solving for b square minus 4ac. Get two values of x from these and this. And then whatever are the two values of x, that should be divided by 2 to get this point's x coordinate. It should not be minus b by 2a. Ritika, I'm making you think.
Yes, I'm thinking.
Okay, so here, very simply put, okay. Now let's look at the concept part of it. I know this looks quick, but this may not be correct. Now, see, what is that we are trying to find out? If I have a parabola and if it touches the x-axis at two places, certainly my vertex will be in the middle of this. The value of x will be this plus this x value divided by 2 for sure. So I have to find out the x value of this and x value of this. Add them together and divide that by 2. If this is 3, this is 8. So 3 plus 8, 11 by 2. 5.5 will be my x value for this point. So here, I would not go for b minus b by 2a. Because minus b by 2a gives me only one solution. My discriminant is 0. It tells me it's touching only at one point on the x-axis. It might be touching in two places. I would, my approach would be, I will solve it for this, saying okay, this is where it's touching the x-axis, be it one place or two places. If it's touching only one place, that means your vertex is here. If it's touching at two places, then I will find out the x value by solving this one. Pick x1 and x2, both the values, divide that by 2, that would be my x value for this one. And I will substitute that value in this equation because this is my contract. That gives me a corresponding y value, and that's my solution. Do you agree?
I agree with you, but also, what if you don't know what your solutions are? You're only given the standard form, and then if you want to find out the vertex, then you could use the formula. But if the numbers are really huge that you can't solve it to find a solution, then it would make sense to use the formula.
So here, see, I'm just talking the conceptual part of it.
Uh-huh.
I'm saying the numbers are big, you cannot solve it, you can solve it. First attempt would be find out the discriminant from this quadratic equation. Once you find out the discriminant, if the discriminant is 0, you're done. Whatever is the x value minus b by 2a, that is the point where it is touching the x-axis and just going back again. But if discriminant is not 0, then you are potentially getting two answers for x. Meaning there are two places where it's touching the x-axis. And then you can find out the x value for both of them, divide that by 2 or get the average of this, and that becomes your x point for this vertex. And then apply that value for x to get the corresponding y value for the vertex. And this is an interesting discussion. I'm loving it, okay? I'm literally loving it. So let's think about it, and when we solve few problems, I will suggest you guys to solve few problems with this parabola in the Khan Academy. Take the unit test and tell me if the approach that I was recommending versus what we were initially talking about, which one is working better for us. I'm not trying to prove that my approach is right or your approach is right. I'm saying which approach is working for you to get the right answer for you in the SAT exam. Yeah? Let's try that out. Make sense?
Yes, sir.
Let's try a few problems, okay? I mean, again, I always keep saying my kids, I don't trust you. I trust each one of you, but I don't trust you when it comes to solving maths. I would rather solve it myself to be sure about it. So same thing I tell you guys, you say, okay, I don't trust you. You said something, let me try it myself, and then I'll tell you whether I agree with you or not. Yeah? So that brings us to the end of the class. I see some of the junior kids also have joined. So for all the senior kids, you guys have a great weekend. And if anybody has any question, any doubt, anything that we learned right or wrong, always send me a WhatsApp message saying, okay, this one probably is a little different, we can do something else, or I think this is the right solution for this one. Okay, I being right or wrong is not important. You guys have to be right when you give the exam. That's the intent. Yeah. All right.
Yes, sir.
So see you guys on next Saturday, and before that I would want you guys to play with some of those quadratic equation problems, graphs, and then we'll meet again next Saturday. And before that, you guys will give me the list of topics that you want to prioritize for yourself. Okay, looking at the Khan Academy.
Bye, sir.
Bye bye, bye bye, take care.
Bye, sir.
Bye bye, bye bye.
Bye.